Alright, the next lecture is on glass box concept, so let's take a look at it. So this concept, we assume that, or imagine we have an object, and that object is suspended inside a six-sided glass cube. Okay, so here is your cube, and of course if you count the side, you have 1, 2, 3, 4, 5, and then the bottom is the 6. You have 6 sides of this cube, and we completely take it like there is an object suspended inside of this box. And of course, since we're imagining, let's take this box like a transparent box, and we call it a glass box because we can clearly see the object inside of it. Then we're going to view the object inside of the box from a specific orientation. Okay, so here from this direction. So your rays, of course, project from the object, okay, to the plane. So here I'm going to take this side, alright, as your projection plane, and here the rays are going to come out of this object onto this plane. So now I'm going to go ahead and put arrow so you know how the visual rays are going, okay, like this. Of course you're viewing from here, don't forget this is your plane, yeah. So I'm just gonna show you that here this is the plane that we're looking at. So you will be cutting your 2D projection on this plane, and this is your pictorial or three-dimensional object, okay? And we're getting the 2D of this 3D on this plane, and you've got, don't forget, 6 sides, alright? So 6 planes. Alright, so now you can see it look neat and tidy, a very nice 2D. And these are your visual rays here, yeah? So we've got a 2-dimensional projection is completely formed on this plane by these visual rays, because without the rays it will be difficult for you to capture the image of it. Okay, don't forget about your photography. It's the same process that we capture our image. We are 3-dimensional, and we got our photographs on a plane, and that's your 2-dimensional, of course, image. So now you got it. You have your 3D. We use the visual rays that's out there in nature, and we capture it on this, or in other words, project it on this plane, okay? And we get a 2-dimensional image on it. We do the same thing, and this is your right side view, because it is on the right, because you're right here, so that's your right and that's your left, and here that's your top, yes. So see this little, right, all the features are perfectly captured here, yes. The only difference is that's a 3D and that's a 2D. Now we have 1, 2, 3 views: your top, your front, and your right. So 2 to 3, okay, all the views is sufficient, yeah, to describe your 3-dimensional object. Unfold your box, so we get the multiple views. And of course, they're two-dimensional, so we've got them on our XY plane. Okay, so that's what it's talking about. Now we're going to flatten it out to make it really nice for us to take a look at it, and you have your top and your front and then your right side. Yeah, so it's kind of like this one was on this side, remember, and that's your front and that's your right side in the box. And don't forget, they are in relationship to each other, and these lines right there, see, they're connected. If you look at it very carefully, see the outer, yeah, border of each view, see, are related to each other, meaning like your two-dimensional projection. See that? It's the same scale, yeah. See this edges to edges and edges to edges, the same, okay, the same dimension. And the features, same thing. All right, it's just a little bit difficult to look at it. Of course, you also have the, see, these are internal features that we can be able to see that whole, yeah, on your three-dimensional object. So again, don't forget this relationship, okay, to each other, to what? To your views, yeah. So the lines, now we're going to give it a name. We call them the projectors or extension lines, yeah. Here, and they're perpendicular to each other. Perpendicular meaning like if you measure the angle, you're going to get 90 degrees to each other, yeah. So that's why it's very pleasing to your vision, yeah, because you can be able to see it very proportional to each other, so it's nice in your eyes. Of course, they have particular dimensions, so we can put that measurement or dimension data into it, okay. So these are, right now you don't have to know, just know that we can add the dimension data to the views or the drawing, okay. We have, of course, object lines, we have hidden lines, extension, this is object lines, hidden lines, yeah, extension lines, and dimension center lines, right. They are different. These lines are not like whatever line. There are their thickness, right? Their thickness are different. So object lines is about like 0.03 to 0.04 thick. Hidden lines is like 0.015 and 0.02. And extension and dimension and center lines, yeah, they're thin because they're at like 0.007 to 0.010. So that's pretty thin, yeah. So therefore, it's really important if you are doing a hand-drawn, not the application drawn, hand-drawn, you have to have like different drawing pencils with different thickness of your lead, okay? Alright, so this is just a shorter video. You can be able to watch it and you can see, you can visualize the glass box concept. See all 6 sides and views, yeah, pretty short, and we can play it again. Or I can just go little by little. See the object is in the glass box, and then we have 6 views, yeah, your top, bottom, front and back, and your right and left. Then you can see the 2-dimensional projections coming out from that 3-dimensional object, okay? Well, I think you got it. So I'm just gonna go ahead and finish it.